we need to simplify this expression. So how do we do it? I'm going to show you this rule that's a shortcut, and then we're going to look at why it works. So to multiply the powers with the same base, what that's talking about is that these two things are multiplying each other, but the bases are exactly the same. What's a base? It's whatever's attached to the exponent. So you see our two exponents, the 2 and the 4, they're both attached to 3's. And so if they're multiplying each other and they have the same base, then we want to keep the same base. 3 and 3, let's put a 3 over here. So there's no thought there, just copy whatever the base is and put it here. Make sure it's exactly the same. But what do we do with these pesky little exponents? Well, after you've kept the base the same, you just add the exponents and put the new exponent right beside the base. Two plus 4 is 6, so it's 3 to the 6th power. We've simplified it. Why does the rule work? Well, let's come over here and let's just recopy the problem so we can look at it. The exponent simply means how many times the base is going to repeat itself in multiplication. So we have two 3's that are multiplying each other. The bases are repeated. Over here, this base is going to be repeated 4 times, but they're going to multiply each other. But this multiplication symbol would come down and show that these 2 bases here would multiply these 4 bases. And since they're all the same, that's the reason we're like, hey, are the bases the same? You could just go and count them up. 1, 2, 3, 4, 5, 6. But why would we want to do that if we could just say, hey, 2 plus 4 is 6? So there are multiple ways to get here, but we're looking for the easiest way. And if this said 400 and this said 22, I don't think we'd want to count up 422 3's. So as a result, I would recommend that when we're seeing that the same bases are multiplying each other, just add your exponents. Go try these 5 problems real quick. Make sure that your base is exactly the same when you rewrite it. Now, let's take a look at one other scenario that's going to come up quite often. If no exponent is shown, then the exponent is going to be a positive 1. So, you can see that this x right here has no exponent. So, using our rule, put a 1 right beside it. Now, all 3 of our bases are the same. They're all x's. So, put your x right here. And also, just to reemphasize, we can only do this type of rule when they're multiplying each other. See the multiplication dots, or the fact that it's understood they're multiplying? So that's when I can steal the same base and add the exponents. 1, 4, and 5 becomes 10. Okay, why do we have to put the 1 here? How can I just not, why can't we just say 4 plus 5 is 9? Let's come over here and copy our problem again so we can look at it. And I'm spacing it out and writing it a little bit higher so we've got some room here. At this point, you should be okay with x to the 4th, meaning that there are 4 x's multiplying right there. And x to the 5th would mean that we've got 5 x's multiplying here. Now, this multiplication dot would come right down and land right here. 4 here, 5 there. Yep, that is x to the 9th power. But what about this one? Well, think about it this way. Even if there's no exponent on here, there's still 1x, and it's just sitting there. And this multiplication dot, the symbol, is sitting right here. So if we're just adding the exponents and keeping the base the same, we'd get x to the 9th power, but there's really 10 x's on here because, yeah, it is sitting there. So in order to help us, go ahead and write in the 1 for the exponent right there, so that way you can go 1 plus 4 is 5, and 5 plus 5 is 10, so you'll get the correct answer. So just be careful. If you don't see an exponent, it's pretty important to know that it should be a 1 there. Now we're going to get to the spot where we put all of our skills together, okay? So let's look at this. Even though they're sitting side by side, they're really multiplying each other, right? They're all multiplying each other. And I had a teacher in 3rd grade that did a really good job of explaining 2 times 3 is the same as 3 times 2. They called it the commutative property. It's where you can rearrange the order of everything that's multiplying. So let's put all of the numbers together that don't have exponents. So the 3 and the 5, let's just put them together. Let's put our x's together and our y's. So you might want to do this rewriting. You could kind of skip this part right here and you could rewrite it to where you could put everything that's similar together, and then you just come straight down the line and go, well, 3 times 5, they don't have the same base, so multiply them. X to the second times x to the third, keep the base and add your exponents. And then y times y to the second. And that would be our answer, 15x to the fifth times y to the third power. That's simplifying. That's putting everything together. Now, some people do not want to go through and rewrite all of this, so let me go show you another way. Because you know that everything is being multiplied together, you could take the 3 and the 5 that have no exponents and just literally go, hey, 3 times 5 is 15. So what about our x's? Well, since they have the same base, still the x, and then add your 2 exponents. 2 and 3 is 5. And then our y's are left over. You'll notice I went ahead and wrote in the 1 so I won't forget, so it's going to become y to the third. So that's a culmination of everything that we've looked at today. How about you go try this very last one, however you want to do it. You can rewrite it to put them side by side, or you can kind of, work your way through like we did the second method of simplifying that exponential expression. For my people without colored pencils, you might want to just underline the 4 and the 6 and go, hey, they multiply together to get 24. Maybe put 2 lines under the a's, so a to the third times a to the first would be a to the fourth. And then b to the fifth times b to the fourth would be b to the ninth. The next video, I'd like to take you through the scientific notation, so just look for video 2 for this lesson, okay?